Hello, my name is Jackson Woolwine.
And my name is Carter Gorley.
And this is our MEGN 200 final project, Arduino project. We have a portable air quality sensor.
All right, and with this portable air quality sensor, we're trying to just detect harmful gases in the air, and our customers for said portable air quality sensor are just people who are concerned about their current living environments and the air quality that they may live in or work in.
So pretty much just our main customers are just the people who are kind of just in the market looking for something, or just looking for a reader or something to tell them what their air quality is. The main problem that they're facing would be like, maybe they just bought a new house for the first time and they just learned that, from their neighbors that they need to have an air quality sensor in their house. Or, maybe they just learned from like a doctor or something that they got a bad lung, disease, and they need to, watch out, for their lung health down the road. So essentially our Arduino project here is pretty much just the main solution is we want to be able to get people, that the correct information on how to, potentially have a healthy living environment in their own house.
And pretty much so.
So our, I guess just pretty much our Arduino project's just going to solve that based on just, reading the numbers based on your carbon monoxide, reading the carbon dioxide in your house, reading the alcohol levels, or just detecting any other harmful gases that, maybe be, pretty bad for your own health.
All right. And here we'll show you a demonstration of, it currently working in just the air of our house right now. So here I have it connected to the Arduino, and I have a battery inside as well. But I have it connected displaying the temp, humidity, CO, and CO2 serial printing. Right now you can see the Celsius that we're rocking with, the carbon monoxide and carbon dioxide levels, and you can see it here being displayed as well, being printed off on the serial monitor. And here I have it set off by a button switch, and which pressing down the button switch will display what we're trying to find, the carbon monoxide and carbon dioxide levels. You can see right here, we're at a resting probably 1.6 parts per million and 3 parts per million for monoxide and dioxide. And then for our exciting little demonstration, I'm gonna take it off the Arduino, or I'm taking it off my computer. One sec, sorry. All right, and we're gonna take it outside to show the levels when the car is started. All right. He's starting his car, or are you?
No, I think we just gonna use it.
All right. Yeah. Here, you take
the cameras.
Yeah.
So this is a cool little demonstration that we're going to show, is to show that our reader is reading very correctly. So like if you ever had, a bad situation where you had a ton of carbon monoxide running, kind of like the exhaust is right here. So we have our car is started so far. So we're just going to pretty much put our sensor up into the carbon, or up into our sensor here.
Show them, yeah.
And you can see that our carbon monoxide and carbon dioxide numbers are significantly higher in the parts per million than it is normally in the house.
Yeah, before we were at 1 parts per million with carbon monoxide and 3 in carbon dioxide, and right now we're fluctuating between 50 and 100 for carbon dioxide, just showcasing the differences.
Right, that's right on that exhaust pipe right there.
Yeah, that's true to me. But yeah, and also the humidity drastically went up. That's right.
So yeah, that's a pretty cool, demonstration of that our sensor is working actually pretty accurately. Right, I'm sure you wouldn't have a car pretty much, blown exhaust into your house, but this pretty much just shows you that like if you ever had, a gas leakage in your house or something, that you could have your carbon monoxide detector be accurately read.
Yeah. You can see it's still recovering from being under the exhaust of the car. Yeah.
So let's take it back inside real quick just to show those numbers again. All right, we're just going to show you the numbers back in our own house here just to show that this sensor is working accurately. Just one more time. So we're just gonna plug this into the computer again.
All right, and there we are.
So we're right back. Look at the serial monitor, and you can see how it is at 1.44 parts per million for carbon monoxide and around 3 parts per million for carbon dioxide. So a lot less in our own house here, which is, you know, a good thing. Yeah, typically looking up your numbers, your carbon monoxide should be around 0.5 to 2 parts per million in your own house. So we do have a pretty safe living environment here, and that's, you know, kind of the number that you'd want to be at. Definitely not near the exhaust levels where you have close to, you know, 100 parts per million of carbon monoxide.
Yeah, and there we are.
Oh, yeah.
That's it. And then I guess you just want to showcase the inside. See how the part's working.
We'll just do that in the second
Ooh.
video.
What about the SD card? Should I just show that now or no?
Yeah, we can just show that now.
Yeah. And so, like you said, for us to incorporate, so we have our SD card wired up here, as well as the battery, which we ran during that test. Oh, just so we had to connect it to the computer just to show you the serial monitor and everything working and displaying all the things separately. And there we are, just all the wiring, the SD card to save the data that we collect.
Show the
in our
levels
code.
again real quick, just to show that they are changing.
Yeah,
So
they
see,
are
carbon
changing.
monoxide is at 0.76 now.
Yeah, see, it severely decreased from when we were outside under the exhaust of my car. All right, and there we are. Everything's changing and fluctuating as needed or as working. And yeah, that is our battery connected. And obviously, I just wanted to say that for the sensors, the MQ135 sensor, our air quality sensor, which detects the harmful gases, it detects it by measuring the fluctuating in the analog signal that gets sent through the breadboard. So this will measure it, and as seen in our code, it'll just measure the changes and which it will be used to calculate the CO levels and the CO2 levels, and therefore then display it on our board and here as well. Here we are.
Cool.
And there we go. Thank you.